Example 5. The general issue license plates in Texas currently have 7 characters that consist of 3 letters out of the alphabet's 26 letters, followed by 4 digits from 0 to 9. Vowels are not used in general issue plates, but they are used in personalized ones. How many different Texas general issue plates are possible? All right, so there we are. We have a picture of a general issue Texas license plate. You've seen them as you drive around, and this is real information. This is exactly how a Texas general issue plate is constructed. There are always 3 capital letters followed by 4 digits. And as far as the letters go, there are no vowels, okay? I never paid attention to this until I wrote this problem. Really, if you drive around, there are no vowels in the Texas general issue plates, okay? So we're trying to figure out, based on this information on how Texas general issue plates are constructed or put together here, how many different plates are possible, okay? So we're going to put down our blanks here, okay, based on, 1 blank per character, okay? So I'm gonna draw some blanks here. So we have 1, 2, 3 blanks for the 3 letters, okay? So we'll say this is letter number 1, this is letter number 2, letter number 3, and then you've got the little Texas symbol. I'm not gonna draw Texas for you. I'll just put Texas and put a little circle. And then after that comes the 4 digits. So 1, 2, 3, 4. Okay, so we'll call this number 1, number 2, number 3, and then number 4. All right, so then we're just going to go to each blank and we're going to fill in how many characters are possible for each position. Okay, let's start with the letters. Okay, so we know what are our possibilities for letters. Okay, we know we're dealing with only capital letters. Okay, so there's no lowercase letters involved here. Okay, so that's 26 capital letters we're dealing with, but we have to take out the vowels. Okay, so we have to get rid of A, E, I, O, and U, the standard vowels. Okay, so there's 5 vowels, so there's 26 letters in the alphabet. Total, we have to subtract out the 5 vowels. So for each letter, we have 21 choices to choose from, okay? So if we start on the left side of the license plate, okay, so for letter number 1, there are 21 letters to choose from, okay? The capital letters, no vowels, only the consonants, okay? All right, now keep in mind, we can repeat letters, okay? There's no mention of any kind of restriction as far as repetition goes. You can repeat letters, okay? So for letter number 2, you're gonna have the same choices, okay? The 21 consonants of the alphabet, okay? So 21 options for letter number 2, and letter number 3, you also have 21 options, okay? So there you go. There aren't any restrictions on the letters except for the vowels being taken out, okay? In actuality, there probably are some additional restrictions. So for example, we wouldn't have letters that come together and form like a potty word or something, okay? But we're not going to take that into account in this problem. We're just getting rid of the vowels, okay? All right, so moving on, now we've got to look at how many choices we have on the other side of the plate. So for the digits positions, okay? So remember, when you hear that word digits, okay, digits are talking about the numbers 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, okay? So remember, there is no 10 digit, okay? Think about a keyboard, okay? You're going to see the number 0 to 9, okay? So those are your digits. You count how many digits are possible, so count these numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? There are 10 digits, okay? So for the first position with a number, okay, so this character right here on the license plate, there are 10 possible numbers to choose from, Again, there are no restrictions on the numbers, okay? We can repeat numbers. So when you get to the second position, so that would be right here, for example, number 2, the second number, okay, there are still going to be 10 options for that character, okay? There's 10 digits you can choose from to fill in the number 2 position, okay? Again, the third number in the license plate, okay? Again, you're still choosing from the digits 0 through 9, so that's 10 choices. Same thing for the last number, okay? You're choosing from the 10 digits available, okay? So 10 possibilities for that last position, okay? So we've got all our blanks filled in. We just need to multiply all these numbers together, okay? So it's going to be a big number. All right, I don't know what this is, so I'm going to go to my calculator. All right, so I'm going to do 21 times 21 times 21, and then times 10 times 10 times 10 times 10, okay? And that's going to give me how many total different Texas General Issue plates there are. Okay, so let's go ahead and write that number down. All right, so we're going to get, this is this number. All right, so let me go ahead, let me check to make sure that is right. Yep, 4 zeros. Okay, so let me go ahead and put my commas in. So let's see right here. Okay, so here's your final answer. Okay, so there are 92,610,000 possible different Texas General Issue plates. And like I said, this is based off of real data, okay? Drive around, this is exactly what a license plate looks like in Texas. If you've never paid attention to the details, okay? All right, let's move on to example 6, okay? Example 6 has to do with a combination lock that has 5 wheels, each labeled with the 10 digits from 0 to 9. How many 5-digit opening combinations are possible? If digits can be repeated, if no digit can be repeated, and then if successive or adjacent digits must be different, okay? So same kind of problem, little bit of a twist because now we have further restrictions due to repetition, okay? So make sure you know what I'm talking about when I say a combination lock with wheels. Okay, so I found a picture of one for you. So it's this kind of thing, like something you would put like on a locker. But again, you've got the 5 wheels there, and each wheel, you would choose a number as your combination, and you're just choosing from the digits 0 through 9, okay? All right, so this is, keep this in mind, this is the kind of thing that we're dealing with here, okay? All right, so let's start with part A, okay? So part A, digits can be repeated, okay? So for example, remember what you're doing here, you've got your combination lock, your combination is going to consist of 5 numbers. And in part A, the numbers could be repeated. So for example, 99999 is a valid combination, okay? So let's talk about how many possible combinations there are if the digits can be repeated, okay? So again, you're just going to do the blank thing, okay? You're going to have one blank for each position, okay? So you've got your 5 wheels, okay? So wheel number 1, wheel number 2, wheel number 3, wheel number 4, and wheel number 5, okay? So again, you're going to go to each position and fill in the number of possible choices of digits for that position, okay? So again, as we've seen with other problems, we are dealing with the digits from 0 to 9, okay? And we've counted those before. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 10 possible digits, okay? And repetition is allowed in part A, okay? So if we go to, I'll say this is wheel 1, wheel 2, wheel 3, wheel 4, and wheel 5, okay? For wheel number 1, you can pick any of these digits. There's 10 possible numbers to choose from, okay? So then for your, moving on to set your combination, you go to wheel number 2. Repetition, digits can be repeated, okay? So even if you, like, say, for example, in the first wheel, you chose a 5, okay? It doesn't matter. You can repeat digits, so you can still choose the 5 again. So you're still going to have 10 possible numbers to choose from for wheel 2, okay? Same thing with wheel 3. You can repeat numbers. So there's still going to be 10 digits available for wheel 3, for wheel 4, and for wheel 5, okay? You can pick any of the digits for any of the wheels as long as repetition is allowed, okay? So now we're going to multiply all these numbers together, okay? This is the same thing as taking 10 and multiplying it by itself 5 times. So this is 10 to the 5th, okay? I will go to my calculator and figure out what this is. So here you go. Okay, so let's count our zeros. 1, 2, 3, 4, 5. Okay, so that's how many possibilities there are here. Okay, so let me move this over. This is going to be 1, 2, 3, 4, 5. Okay, so let me put my commas in. So basically that is 100,000 combinations are possible. Okay, all right, so I'm just checking my numbers here. Yep. All right, so that's how many different combinations are possible if digits can be repeated, okay? So let's take a look at part B, where now we start using some of the restrictions, okay? So now we're gonna take a look at it and say, okay, now digits cannot be repeated, okay? So again, what you're gonna do, you're gonna have the same kind of setup, okay? You're gonna have your 5 blanks representing each wheel, okay? But now we're going to have to change things up a bit, okay? There's a little bit of a restriction here. You can't repeat digits, okay? So we're just going to go to each blank and again, fill in the number of possible choices for digits for each wheel, okay? All right, again, we're choosing from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, okay? All right, let's say again, I chose number 5, okay? Well, okay, for wheel 1, let's start with wheel 1, okay? You can pick any of these 10 digits to be in the first position, okay? So there's 10 numbers to choose from. Let's say I chose 5, okay? Since we chose 5 for wheel number 1, okay, we cannot repeat the 5, okay? So I scratched it out here, okay? So if you look, now I can choose from the digits 0, 1, 2, 3, 4, 6, 7, 8, and 9. And so there's 9 possible numbers to choose from now, okay? So let's say for the second wheel, I'm making this up. Let's say I chose 8, okay? So now I can't use the 8 again. So for the third wheel, how many options are available? Well, I can pick from the 1, 2, 3, 4, 5, 6, 7, 8 remaining digits, okay? All right, so let's say for wheel number 3, I chose a 0. Okay, so I'm going to scratch that out. So when it's time to pick a number for wheel number 4, okay, I can pick from the 1, 2, 3, 4, 5, 6, 7 remaining digits, okay? And then let's say for wheel number 4, I chose a 9, okay? Can't use that one again because we can't repeat anything, okay? So for wheel number 5, my last wheel, I can choose from 1, 2, 3, 4, 5, 6 remaining digits, okay? And that's it, okay? So that's what's going to happen here if you cannot repeat the digits, okay? So we're going to multiply these numbers together. Okay, so here we go. So I'm going to go to my calculator, okay, and we're going to have 10 times 9 times 8 times 7 times 6, okay, and this is how many possible combinations there are, okay. So 30,240, okay. You can see with this extra restriction that you cannot repeat digits. It really narrows down how many combinations are allowed. Okay, because remember in part A, when you could repeat digits, we had 100,000 total possible combinations. But now that you can't repeat digits, it's narrowed it down. There are only 30,240 possible combinations. All right, let's look at part C, okay? So now the restriction is successive digits must be different, okay? So adjacent, that word adjacent, this is what is like your direct neighbor is how you want to think of that, okay? So like, for example, if I had, my 5-number combination, if I had a 9 right here in the first position, then the next digit would have to be different, okay? So maybe this could be an 8, okay? But then when I got to the third wheel, okay, what happens here, it can be 9 again. So you can repeat the digits as long as the neighboring digit is different, okay, if that makes sense, okay? So that's what's going on here. So again, to figure this out, you want your 5 blanks, 1 blank per wheel. Okay, so we've got wheel 1, wheel 2, wheel 3, wheel 4, and wheel 5. Okay, again, we are choosing from our 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so for wheel number 1, okay, you can pick anything. You can pick anything out of the 10 digits. Okay, so there are 10 choices for the number in the first position. Okay, so like I said, say I pick a 9. Okay, so if I pick the 9, wheel number 2 cannot be a 9. Okay, it has to be one of the other numbers because this second wheel, whatever number that is, it cannot be the same number that is in wheel 1. Okay, so that means there are 1, 2, 3, 4, 5, 6, 7, 8, 9 digits available for wheel number 2. Okay, and then like I said over here, say now that I pick, okay, say that I picked 8 in the second position. Okay, so in the second position, let's say we picked an 8, okay, like I was drawing over here, okay? So what that means is that the number in this position cannot be an 8, okay? So it can be any of the other numbers, okay? You can go back to the number in the first wheel, which I said was 9 in my little fictitious example here, okay? So the only number this can't be is the 8 that is in wheel number 2 position, okay? So again, you have 0, 1, 2, 3, 4, 5, 6, 7, and 9 to choose from. That's a total of 9 digits that are possible for wheel number 3, okay? So like I said, I'm kind of making up an example over here, okay? So when we get to wheel number 3, okay, I told you I pretended to pick a 9 in that position because you can repeat digits here as long as side by side the direct neighbors are different from each other, okay? So for wheel number 3, let's pretend I picked the 9, okay? So I'm going to go ahead and I'm going to scratch out the 9 for this case, okay? So let's say I pick a 9, okay? So for wheel number 4, okay, this position, I cannot have the same thing as the neighbor, okay? So for wheel number 4 right here, okay, can't be a 9, can't be a 9, okay? So I'm scratching out the 9. It can be any of the other digits, okay? So it can be anything from 0 to 8, okay? If you count that up, that's 9 numbers to choose from again, okay? All right, let's say I pick a 1 for the wheel number 4, okay? So now it's time to pick the last number, okay? So let me go here and erase this. Okay, so let's say I picked a 1 for the fourth wheel. Okay, so I've got to scratch out 1, okay? Because for wheel number 5, what's going to go here, it can be anything as long as it's not a 1, okay? So again, if I scratch out the 1, what are the possible digits that can go in the 5th position? Okay, anything but a 1, okay? And that's 1, 2, 3, 4, 5, 6, 7, 8, 9 digits to choose from. Okay, so that's how you work this one. Okay, multiply these numbers together. Okay, and that will give us the total number of combinations for this particular one. So let's go figure it out. So we're going to have, let's see here, 10 times 9 times 9 times 9 times 9. All right, there we go. So this is going to give us 65,610 possible combinations here. All right, let me make sure that is right. Yes. All right. So that's how many different combinations are possible, okay, if the successive or adjacent digits have to be different, okay? All right, let's move on to the last example, okay? So let's take a look at example 7, okay? A college offers 2 introductory courses in history, 3 in science, 2 in math, 2 in philosophy, and 1 in English. Okay. In part A, it says if a freshman takes 1 course in each area during her first semester, how many course selections are possible? Okay. All right. So what we have here, okay, we know what the college offers. Okay. So 2 courses in history, 3 in science, 2 in math, 2 in philosophy, 1 in English. And here we have this freshman who's trying to take 1 course in each area during her first semester. And we're trying to figure out the possible number of ways that she can choose her courses. So again, you're going to use the multiplication principle here because this freshman has choices. Okay, so put your blanks. Okay, 1 blank per choice. We're going to have a blank for the history choice. We're going to have a blank for the science choice. We're going to have a blank for the math choice. We're going to have a blank for the philosophy choice. And we're going to have a blank for the English choice. Okay, so now we go to each blank and figure out how many different possibilities there are for each position. Okay, so for the history courses, okay, there are 2 history courses for this freshman to choose from. Okay, all right, and then for science, there are 3 possible science classes to choose from. Okay, maybe the freshman can choose from physics and chemistry and biology, for example. Okay, 3 different choices there. Okay, math, there's 2 different math classes to choose from. So put a 2 there. Okay, there's also 2 philosophy classes to choose from. So put a 2 there. Okay, and then there's just 1 English class. Usually there's a freshman English class that you have to take. So there's only 1 course in English to choose from. Okay, so we've got all our options in there in the blanks. So now we're just going to multiply everything together. Okay, so 2 times 3 is 6, times 2 is 12, times 2 is 24, times 1 is 24. Okay, so there are 24 different course selections possible for this freshman. All right. All right, so let's go take a look at part B. Okay, part B says, all right, we've got a part-time student now. Okay, and that part-time student can afford to take only 1 introductory course. How many selections are possible? Okay, so you've got this person, they can only afford to take 1 course, 1 course. And we don't know which one. We don't know if it's going to be a history course, a science course, a math course, a philosophy course, or an English course. We don't know. Okay, they can only choose 1 course. Okay, so we have to figure out how many possibilities there are. Well, it's a little bit different here. We're not doing the blank thing because think about it this way. How many classes are possible? Well, there's 2 histories possible, 3 science possible, 2 math possible, 2 philosophy, and 1 English, okay? And they're only choosing 1 course, okay? So what we're going to do here is add because we're looking at overall how many different classes are available, okay? Because we don't know anything specific. We don't know if it's going to be a math class. We don't know if it's going to be a philosophy class or whatnot, okay? So we're just going to add the total number of classes here because the person can only take 1 class out of everything offered, okay? So we're just trying to figure out the total number of offerings here. So this is going to be 2 plus 3 is 5, plus 2 is 7, plus 2 is 9, plus 1 is 10, okay? So for this one, this part-time student, okay, there's 10 selections possible, okay? And that means, they're picking 1 course out of all of the ones available.